All right. Well, welcome everybody to the Raleigh Software Craftsmanship community. And so we're a group of um, crafters, developers, and language agnostic, and sharing our successes, failures, and really, talking about better ways of working and, practicing uh, technical excellence and those kind of things, and just trying to improve every day. Um, so just a few announcements before Arlo takes over. Next month, we'll be having Alex uh, Bunarzik, and he'll be talking about how I learned to develop software like a bureaucrat. And then in June we'll actually start meeting in person a little bit more often and take a break from our online series. So if you're in the North Carolina, Raleigh area, come out and join us. So I'm gonna pass it to Arlo, and he's gonna talk about some legacy code stuff and how to avoid rewrites.
No, thank you. And yeah, looking forward to chatting here. I recognize many of the people here on the screens, and some of them not, and great both ways. And so I'm going to talk about legacy code. Don't trust too much the title or abstract that I gave way back when we talked about what I was going to talk about, because while the content is mostly the same, plus or minus having evolved, all titles have been modified just for funsies. So let's go ahead and share screen. Hopefully all of this works. So I'm going to talk about navigating from DevOps, from legacy messes to DevOps mastery. Right? It's a long, long road between the two, and we will talk about uh, how did people get there frequently. So where this comes from is so I'm giving a talk at Craft, and at Craft in June or something, I'm going to talk about the path and journeys from legacy pain to legacy joy, all the wonderful things that happen there. And I decided that being not so ambitious, I was going to write down literally everything I knew about mentoring people, about technical excellence, about the transition and paths between there, the multiple and many routes, and put it all in a set of diagrams that were easy for people to reference and use and could drill into what they wanted. And I was going to create all of that between now and the craft conference. So I'm in the process of writing down basically everything I know about teaching and doing tech. And along the way, I have learned a few things because basically I can't help but anytime I look at something, I have some insights and then I write them down and then I keep doing that. And out the side of that comes this talk. So this talk is originally it was going to be an early version of the talk I'm giving at Craft, and now it is totally unrelated. It's all the insights that I've had while I was writing down what I already knew. So it's a little bit of pick your metaphor. Maybe it's a peek behind the curtain. Maybe it's a trip to the sausage factory. I think that depends a lot on you and your experience of where we go here. So let's take a look. All right. So first, I want to show what I am building because we need some context. So this is a big diagram. And this would be one of several diagrams. I'm actually going to be creating a lot of maps because the first thing that I realized as I was starting to write this down is that there are a bunch of different goals that people have when they're talking about getting to DevOps or getting out of legacy code. Right? And I roughly categorized them and found, I've forgotten whether I had 7 or 9, but a lot. And each one of them is fundamentally different. Um, one of them, the one that's the map that we're going to be playing with today here, is about escaping a monolith and getting out of a multi-team monolith to the point where teams can release independently. And it's all sorts of goodness and so on. There are other ones about, I'm drowning in the constant maintenance stuff, and I can't even add any new features, right? And there are other ones about my external code quality is too low, and so on. And each of these not only has different goals, it actually has different practices and techniques that people do, different contexts along the way. It's a different evolution, different paths, different experiences, right? So I can't just say, here's the way to DevOps, because there are at least 7 or 9 completely different DevOps meanings. So we're going to look at one of those right now. And I'm building out this site, and we'll build out eventually all of those on this site. So I started to create it, and that was the first insight, was that, okay, I didn't just sign up for one map, I actually signed up for 9. Fun. The second thing is I looked at what was going on here, and many of you may be familiar with the Agile Fluency map that I did many years ago. And if you haven't seen it, I will just try and quickly. Engineering. In some ways looks similar. I tried to map out basically all of the practices and things that I saw people do. And this is technical stuff. It is learning stuff. It's got different styles of pairing and mobbing. It's got many different ways that people do planning, how people handle stories, how people handle ... right? And put it into a similar sort of a sequence. And as I was sitting down to do that, more narrowly refined towards the technical end this time, I realized one of the big changes that I have discovered over the last several years is there are actually 2 kinds of things that belong in. There's the behaviors that people do, and there's the contexts. And the previous map had everything sort of jumbled and mixed, and a lot of things were half of each. So can anyone guess, just from the words, what a behavior might be, either give an example or a definition, or what a context might be? I'm giving you no information, so a wrong guess can't be too wrong.
The behavior is like something you do, like a practice. So like daily releases or unit testing, and a context is, I got nothing
Yeah.
for context. Possibly like the
You're
technology that you're in, like, are you in mobile or are you in web or are you in like, physically delivered software?
Or maybe your team environment in general, the health of your team.
team environment. Yeah, Olaf mentioned maybe like, are you in medical device and regulated? That would be a context relevant thing, right? Okay, so each of these are interesting meanings of context. Behavior is clear and obvious, and yeah, it's exactly that. And I am using it very precisely, right? So in a behavior, I'm meaning exactly what people actually do. And so, for example, when people say unit testing, that is not a behavior, because the words unit testing mean dozens of different behaviors depending on the team and depending on, as it turns out, their context. So the context that I'm meaning here is something that is true about the environment. And I saw a flicker by a definition. Nick Knapp said a relevant scenario specific details, right? Yeah, it's a set of relevant details. And what I was observing, and what I've observed a lot in my working with teams, is that there are these stable points. There are these situations where the whole context changes, right? One example of these, if I look in here, is the ability to ship dark features, right? Before I have that ability, the world operates in one way, in a particular way. Once I have the ability that I can deploy and have code turned off but still be out there, there's a lot of things that are just different, right? So that's a very relevant context. And if I look at practices, at a bunch of my practices, they're fundamentally different depending on whether that context is present or not. I will approach my release game very differently. I'll approach my stabilization period very differently. I'll approach my integration with other teams very differently, depending on whether I intend to ship dark or ship live, and what goes, goes. So that was the first thing that I noticed, is there are these contexts. And I want to start by exploring those. So my new diagram, I actually, when you first open it, even if you zoom all the way out, it doesn't show any of the behaviors at all. Now, I'm a very strong behavioralist. One would think that I'd be showing the behaviors, front and center. Certainly, when I teach, they're all front and center, and it's all about, I teach the fingers, and then your brain will catch up, right? Your fingers will teach your brain, but I'll teach your fingers exactly how to behave. Yet this map doesn't show the behaviors at all. It just shows the sequence of contexts. You have to drill in. I can open up the behaviors that relate to a particular context. So those are the behaviors that lead into that particular context. Any thoughts why I focus on the contexts first?
Well, I think Llewellyn was mostly joking, but it's also feels very relevant. It depends. So which practices you can apply are going to vary by context, and which practices will get you benefit is going to vary by context.
Absolutely. Yeah. Definitely which ones will give you benefit and what those benefits will be. And we'll be exploring some of that later. Varies dramatically by context. Yeah. Okay. Yeah. Another thing that I notice about these contexts is there are multiple paths. And this is kind of related to the first point that you were making there. If I look all the way over to the right side of my diagram here, so the end goal of this map is to be able to ship without synchronizing between teams, right? I start by a monolith as pane, and I want to be able to ship each code base without ever coordinating with business people, without ever coordinating with other teams. I can deploy at will. Now, there are still other activities that involve coordinating with business people and with teams, but most specifically, those are completely unrelated to the deployment process. They're off of that deployment path. And that gives me all sorts of advantages. And what I observe looking out there in the world is there are a whole lot of ways that people try and do this. And there are 3 very well-trodden highways. I think there are other roads as well that get there, but these 3 well-trodden highways are the ones that I see most commonly. And I'm going to loosely call them the ops path, the clean boundaries path, and the monorepo path. Okay. So the ops path. So the ops path is the one that starts with things like feature flagging and telemetry. And it's all about a lot of the DevOpsy, the ops elements of DevOps movement, where we're going to, fundamentally, we're going to attain the ability to ship without synchronizing by completely separating release from deploy. And then I can deploy whenever I want. And independently of that, I can release anything that's already been deployed by doing config changes and watching the telemetry and using all of my automated systems to roll back and roll forward and all these things that I can do, because none of those are a code involved event. Right? And so that whole ops approach is fundamentally about breaking the connection between deploy and release. And there's a bunch of practices and techniques and do that. And if you do that, you can then ship without synchronizing in all sorts of awesome ways. Then there's the clean boundaries approach. The clean boundaries approach says, well, if I have a bunch of people all in one repository, the big problem that's preventing me from shipping independently is all the dependencies between them, right? It's that I make my change and I cause integration bugs on other teams, and I have painful interactions and dependencies across the thing. And so I'm going to create clean boundaries between the teams. I'll create APIs. Now, these might be full formal APIs of the messaging system or whatever, or they might be just a set of classes and functions and memories and in memory, and then you're just making direct function calls. But there's a defined boundary. And there's producers and consumers of each boundary. And there's a way that we relate and a set of things that we do. And when I have those, and then when I add on certain types of refactoring to be able to build those in, and certain types of contract testing, then I can get to the point where I can verify that things will integrate without ever integrating. And now that I can verify integration before I go live, I can also have release independence, right? Because I have these clean, verifiable code bases. Right? So I know when I would break something, therefore I don't break things. Right? Producers don't break their consumers, and we can always ship what's on main. Now that makes it so that my team can just be pushing to main whenever we want, and I've effectively shipped. I can, with my collaborators, collaborate and push whenever we want, and we have shipped. And independently, that can go out to the site whenever it needs to be. Right? So that's another way to handle this, and to have ship without synchronization, and each team ships independently. The third one, this is the one popularized by Google, and we've seen it in a few other places. It's the monorepo path. This is commonly used for really, really, really big systems like Windows, where you put the whole thing in one repo and you create a lot of tooling and refactoring and stuff to the point where anyone can contribute without undue risk across that repository. You eventually develop the skill and tools such that people can safely alter code that they've never seen. Right? And so like Google has refactor by script, where you can define scripts that will do refactorings, and it'll go across the entire Google code base, execute that refactoring, run all the appropriate tests, include all the right people in the PRs, and go ahead, send your PR out for review. Right? So that's a third way, because now when I want to make a change and it screws up a dependency and so on, I'm in a monorepo. I am my own consumer, and I can edit all the code, including both the producer and consumer side, and so I just do so. Right? And so now each team is free to make changes whenever they want and however they want. And so this one kind of sidesteps the thing about it's about deployment independently, and it makes it so I'm coding without synchronization, because I can just alter everybody's code. So I don't synchronize for coding. And since I don't synchronize for coding, then who cares whether I synchronize for shipping? So 3 very different paths. And we're talking about contexts. So I want to just pause for a moment here and think about those paths and how they are so very different. I want to ask you all, which of these is your individual preferred path in the situations that you're in right now? And see if we can get just sort of a raise of hands. How many people currently find the ops path to be optimal for you?
I don't know if it's optimal, but it's what's possible.
That's optimal in your situation. If everything else is impossible, then optimal.
In that context, yes, you're right.
Right? And how many people, or which people, find the clean boundaries and refactoring for separation path to be optimal for you right now? You. All right. And how many people find the monorepo and enabling universal change to be your optimal? I was hoping that we would have enough people and enough representation that all 3 of them are represented, because that's the way it should be, right? Out in the wild, each one is best in some circumstances, and each person's going to have skills that more align with one or the other. You've developed one of them more than the other, almost assuredly. Right? So I'll just do a quick popcorn. People who are in favor of the ops path, what are the couple of the benefits of the ops path?
I feel like ops is usually like the lower hanging fruit.
be really easy to get started.
Yeah.
More generally acceptable.
I think it's pretty well defined comparatively.
Yeah, we as software engineers spent what, half a century or a century trying to define what is good design, but what is a feature flag? Got it. We know it.
Yeah.
Yep. Yep. All right. So similarly, those who like the clean boundaries and refactoring approach, what are some of the arguments in favor of that? The benefits it provides?
It requires agreement from less people.
Yeah, no one else needs to opt in.
Yeah.
Your advantages?
I mean, that's a pretty big advantage.
That's a pretty big advantage. Another one that I find is it's the one that scales to the ugliest code because
Yes.
it involves the ability to be able to safely refactor anything, no matter how terrible it is. And so you can handle the worst code with that approach.
I feel like part of that is because you can do it without other people's permission.
There's a thing I particularly like in there. If a team can own their own code behind a boundary without like crossing that boundary very much, then the teams that invest in their own tooling and abilities benefit. The teams that don't want to go along with that, they don't benefit. And they're not like stepping on each other's, they're not making messes for each other. So you like, there is a reason to make that investment for yourself. And if you do, you rise to the top of the organization as being the most productive team. I like that dynamic.
Economics work out really well. We're doing some investment. Yeah, absolutely. So there's some good, strong advantages there. And for those who like the mono repo path, what are some of the strong advantages of the mono repo path?
Quick feedback. It's easy and fast to see if I broke something refactoring. It's easy to see if some API is used at all by anybody or how exactly is it used, so I can refactor or remove it if it's unnecessary.
Yeah.
You can tell when you've broken something. It can be very easy to debug. You aren't artificially separating things, so you can just follow things in the stack more easily. Yeah.
There's like a variation of this, I think, where it's one team, but they still have like 50 repos that they're managing. That really should just be one repo. Right. So there's a mono repo thing where it's like if it's small enough, it's better to have it in one place.
Yeah, so that's different than what I'm meaning by the mono repo path. Yes, that's true. I would say there's a failure mode of overly fragmenting. And usually I find that's people who are going on the ops path.
Yes.
They're going to services and to a crazy degree, and they get 19 and then 150 completely separately deployable services, and now have to manage all the configuration complexity. So monorepo has the advantage that you won't run into that.
Right. And if it's manageable, it's nice to have it in one place.
Yeah. The other thing about mono, it is. Well, one of the other things that's really nice about monorepo is it's one of the best economically for rewarding the benefit to the commons. It becomes very easy for someone to make a change that is universal. I can improve everyone's code editor. If I make an improvement to my code editor, I check in, everybody, all 100,000 developers gain that benefit. And they don't even have to opt in or think about it. They just get it, right? When I see a problem that I want to refactor
that's also
away,
the reverse, right? Like if I want to improve this, I need to fix it in all 100 places.
So that's true, which is why a successful monorepo has a bunch of investments in tooling and stuff to make that possible. So for example, refactor by script is built in. Every successful monorepo at some point gets that context and has the ability to refactor by script the way that Google does. And so now when I want to change oh, look, I figured out this security bug, and I see that, write a quick linter script. We have 100,000 instances of it. Okay, I'll fix those this afternoon. So yeah, each of them has some strong advantages. Right? And that's the first thing that I noticed. There are lots of paths. Right? There are a lot of paths. Many of them are bad. Some of them are good. And there can be a number of different good reasons to choose between those paths. So, next insight that I had was contexts are stable attractors. They're gravity wells. They've got big springs around them. They're, pick your metaphor. They seem to match all of them. I call this, this is sort of the law of gravity as applied to technical excellence. When I look at any of these contexts, they tend to be stable over time and resist change that would make them untrue. So for example, excellent unit testing. When a team or a set of teams has developed a strong set of excellent unit tests, and they depend on those and are building on those to do all their other things, and those are their safety, those tests don't degrade. When they bring in 2 new developers who are against unit testing, within a few months, those developers are in favor of unit testing. It doesn't go the other way. And the same is true with each of these contexts. Similarly, if you can go all the way down to some of the more contentious ones, a uniform development platform. Everyone's going to use the same IDE with the same configuration. We're going to use the same GUI for source control, and we're going to ... And there's one language that'll be used for scripting. Everyone will have it. It'll be pre-installed on your machine. Getting developers to agree to that and getting them to agree to the formatting standard can be very, very difficult. It's hard to attain this context. Once you have it, it never goes away. People don't bring in the second IDE. They don't want to. They'll bring in a modification that they propose as a new uniform standard. But they won't just go off and do their own, I'm going to do Vim and I'm going to do Emacs, because the value of that context is so strong, it pulls them in. And part of it is, as you've got that uniform platform, now people build on it, right? And so, yeah, I could go to Vim and then I could edit text twice as fast. Or I could stay on the standard thing that we've got here and use all the refactorings that are built in there and the semantic transforms and the AI tools that we built on it. And why the hell do I care how fast I can type letters, right? Because I don't type letters anymore, right? So that's true with every single one of these contexts. They are stable attractors. Let's look at an example. Let's look at that dev platform one. So this context, when you're in that dev platform, everyone has the same development environment, same development platform. It's configured the same way. When you receive your machine from wherever you receive your machine from, the cloud or IT or checking out the open source project or whatever else, it effectively has been imaged with the dev environment. At least once you get source control and start the thing, whatever the startup thing is, it now is uniform, right? And it's got everything that you want and need on it. There is a way to do everything. You can ask anyone in the company, how do I accomplish X? And they all tell you the same thing. And it works. And it works every single time. Right? So that's that context. You can build on it. Everyone can extend it. There's a standard way to do the extensions, standard way to check them in, so on. Prior to that context, or without it, you've got freedom, right? So everyone can do whatever they want, and so everyone does do whatever they want. And on any given team, there are 4 different IDEs. And when you want to talk about, I'm going to do rename, a rename refactoring, it's like, well, okay, so are you using VS Code, or are you using JetBrains, or are you using Vim? Because I have to tell you different ways to do it. And I'm going to trust you differently depending on which those you did, because I know that this one's in Python, and so the JetBrains one is good, but the VS Code one is bad, and that one's in TypeScript, so both the VS Code and the JetBrains ones are good, and so each of those, I argue, is a stable state. So let's have a thought experiment. What is one behavior that you think might be on the path between those two, from the land of freedom to the land of uniform platform, extensible platform? What's a behavior or a change that you think might be on
Hi.
Language server protocol, LSP.
What was that?
Language server protocol, LSP. You can run the same language backend, but connect from any editor.
Yeah, having a uniform language server, and then any editor connect to it. Right? That'd be an example. Yep, Jay.
Yeah, if I add a CI check that the code is all formatted in a uniform way, I think that's going to pull us forward here.
But yeah, there's a behavior of doing a CI check that the code is formatted correctly, or doing a pre-commit hook to format the code all automatically and correctly. Right? Either of those two would be behaviors, right? So uniform language server, uniform configuration for my language server, uniform update so that I'm always on the same version of my language, uniform formatting. Each of those are behaviors that are in that space between the two. Okay. So now, let's assume that I am doing one of those. I'm going to say I'm adding the CI check. I'm in the context of we already have a stable, we have a development platform. So I'm working on these CI checks. I'm in that development platform. I don't have a CI check for this new language that I'm going to do. Assume that no one ever pushes for anything. There's no intentional effort created. There's no director-led initiative. There's no anything. But I'm just in the situation that one of my languages does not do pretty formatting, and everything else does. What happens automatically within the first quarter?
You get about 50 different styles if this language is any popular.
If you've got the system where in all the other languages, it's stable and it's cleanly formatted, and all the rest of our development platform is uniform, and we've got refactoring things that'll build and scripts that'll run as long as the thing is always formatted the same way, and people want to write those scripts for this new language, what happens?
First, they get angry because this is deficient. They have an expectation. It should be this way. And why isn't it like this? The system is broken. And then I think what we're hoping is that anger turns into an action of bringing it into the norm.
One of the angry people changes it. Yeah. It very consistently happens that way. Unless there is an active force pushing it away from the current active context, in this case, uniformity, it will fall in. People will write that. Someone will go ahead and take the couple of days to write that formatter and contribute it. And everyone else around them will give them attaboys because, oh gosh, thank you. That was the rough spot in our uniform platform, and it's gone now, and we all appreciate it. Now, let's assume exactly the same situation. Many of the languages are sort of doing the pretty formatting, but some don't. The context and norm is a bunch of freedom, and that everything is supposed to be is independent, and people are making independent choices. Right? Somebody tries to bring in clean code formatting with the arguments that I'm going to be able to build other things on top of those, but nothing supports building those right now. What happens? Assume again, there's no director or VP pushing. There's no executive driving it. There's no intentional push and concerted effort by somebody. What naturally occurs?
the antibodies come out and attack it.
The antibodies come out and attack it.
I think just generally people ignore it.
Mm-hmm.
A lot of people ignore it as long as they can, and they go off and do their own thing. Yep, that's one of the antibodies, right? Just I'll do my own thing. You're free to do yours.
Or you get the Burger King approach, have it your way.
And then you get 50 different code formats, each with a code formatter, none of which goes outside of my IDE. And every commit includes a reformatting of the code. Right. The thing is, again, the context was stable. So we tried to do the same behavior, but depending on which context was present, the system naturally either pulled us forward or pulled us backwards. So the key thing is the contexts always pull behaviors towards themselves. It takes effort to leave any context. It takes, if you want to go from the current way to a quote better way, it takes effort to leave. Once you've gone far enough away, then that will be pulling less in some ways. But the longer that you've been away, the more it will be pulling you back, right? And it will keep pulling. Right? But as well, when you're close to a new state, when you're leaning into it, or when you're already there and you've got some things that aren't, or something that falls backwards, it'll pull things right back in and naturally maintain that current state. So this is really, really key for adoption as we're trying to make changes. Because let's think about partly done work. I'm halfway through making a change, through changing the way some behaviors work. I posit that there are two different kinds of partly done work that operate fundamentally differently in a system like this. Can anyone guess or think of what might be different kinds of partly done work and how they might behave? Where the quote work is all the effort in changing from context A to context B.
It might be whether or not the partly done work moves you toward or away from the established context.
So in a transition, if you don't pay any attention to it, it will always be moving you away from the established context because I'm trying to go to some new context, right? And so my partly done work is pulling me away from my established context. Right?
Mm-hmm.
Now I put some codicils on there because you can change that, right? But yeah, so yeah, partly done work that's moving me towards an established context is different than partially done that's moving me away from one. But also as I think about assume that I'm going to do all of that work. I'll just expand this out again. There's all this stuff, these behaviors related to getting a uniform development platform. And don't hold me to these being exactly right, but I think they're strongly suggestive. As I'm going through this, and I'm trying to get the whole company to move from context A to context B, I'm 1/4 in. What are two different ways that I could be doing this work that would have fundamentally different effects on the gravity well?
I'm not sure in terms of moving a whole company, but in terms of moving a whole team, if I can put them in a mob, I'm automatically going to start making it painful for them to be on different environments with different so there's going to be a natural gravity well towards consistency.
One of the things that happens when you mob for this particular one is there is uniformity in the human. So if there is now non-uniformity in the tech, it's painful. It sucks. Yeah. And so I have, in some sense, already activated the uniform development platform context without even changing the code at all.
Yeah.
Mobbing is a very effective technique for implementing this one, by the way. Rapid pair swapping also is for similar sort of reasons.
Yeah.
But that really is the key, is my partially done work is in some way activating the new context. And it's making it become the established context, which is what I've forgotten who somebody was pointing out, the whether it moves us towards or away from the established context, right? I've hack established it, right? I could similarly, even if I'm not mobbing or I'm doing groups larger than the size of a single mob, right? If I implement a fully a uniform scripting language, and I build all that out, and I build a really good uniform IDE, and I do it for one of the languages, and I don't build out the other parts, I'm still in the prior context, and everything is eroding my work. However, if I can find a hack that allows me to do a lot of it in some way for some context, I can activate it in a new way. So I might be able to say, all right, what I'm going to do is I'm going to get a through line for just our TypeScript work, right? And I'm going to get the IDE and set it up, but I'm not going to get everything working. I'm just going to get it to the point where it pre-deploys on your machine and has a config that's checked in, and that config is wrong. And then I'm going to get that you can use TypeScript to extend that IDE. That's all in there. And then it also includes an extensible Git experience that has one new nifty thing, and that's showing some of the risk-aware notation, and I'll spread that around. I've got a little activation of each one of these things, right? All within one context. I've now got enough there that there is a core development platform that people are excited to keep contributing and growing to. And someone will extend it to another language eventually. Someone else will give it more capabilities. Someone will bring in keeping things Git clean or feature branching, and then they'll build on top of the feature branching. Now that that's a uniform platform thing that we can depend on, they'll build the thing that does our FDA approval, generates all our documents, so we don't have to do that anymore, or whatever it is that we're building on top of it. That was the next big insight, was these contexts are stable attractors. And going back to, so why did I look at the contexts first? That's it. Because the law of gravity applies. And as I'm trying to shift myself or my team or my company or my industry, if I can in some way use the law of gravity to slingshot my way through this thing, I will go a lot faster and use a lot less fuel than if I try and just push my whole way through with a big ass rocket.
So how do you know you've reached the tipping point where it's going to work or not, or if it's not going to be adopted?
Lots of answers to that question. It's a really, really good question. And first of all, each context has a different concrete specific answer. So part of the answering to that question, I would have to go into a specific context and then have to do it for every context. So I'm going to set that part aside, right? And then another element of it has to do with what your strategy is for enabling the context. And there are a couple of strategies for that. One, which I'm going to talk about later, that has a different answer again. But let's assume that right now, what the strategy that I'm doing is sort of a brute force. There is the old context, there is the new context. I'm trying to create enough things that people start interacting in the new way. Then what I'm going to look for is, for each of these contexts, there are measures that you can observe to see whether people are doing the key behavior. So first, look to see whether that's present. And if it is, then you've got in some way that engine is started, right? And cycles are going to happen. Another thing that you can do very easily is simply step away for a week, right? And see whether teams go forward or go backward. Llewellyn and I had a conversation that impacted us both very strongly many years ago. We were talking about how to be most effective. And we hit on the idea of, when we're working with a team, what we should optimize for is we should have the greatest possible impact when we are not present. Because we will be with a team less than we will be not with the team. And if we maximize our impact, the impact of our absence, then the team will do awesome things. And we will come back and go, hey, okay, where are you at now? Let me reorient and figure out what's coming up, because you have just leapfrogged ahead. And so that's what we're doing here. And one of the ways you can test for it is to just leave. Go work with another team. Go do something else for a little while. Stop pushing or trying and see what happens. If we talk about this as it's simply attraction, right? Then one of the corollaries there is that entropy and healing are the same force, right? This is what we've been talking about. Like, it is exactly the same thing pulling me back as it is pushing me forward. Whichever is the more activated context is the one that's going to pull more strongly. And in the absence of other intention, it's the one that's going to dominate. Unless you are in a fractal, in which case they're all strange attractors and you never touch any of them anyway. Which happens in the real world. So my recommendation is there's an interesting hack that I've found for this. And it's the same way that I handle a lot of legacy code situations. What I try and do is quantum superimpose the two contexts, entangle them, make it so that the system is operating simultaneously in both contexts at the same time. And it might need to be in a very inferior form of one of the contexts, because I've got all the behaviors in there for one context, but none of the behaviors that are necessary for the other one, right? And by behavior, I also mean like tooling and all these other things that are necessary, right? But find a way to superimpose two contexts and make it so that your system is actually already in there. This is, I argue, the thing that SAFe does better than anything else. It's both what SAFe does best and the way that SAFe beats everything. And that is when you first look at the big picture of SAFe and you're outside of it, everyone looks at that and says, I see where my job is. I can do the same thing I've been doing. I don't have to change. And we can do this agile transformation. SAFe allows you to completely adopt agility without making a single change in how you do anything. While that sounds stupid, right? That sounds like, well, that's the point. We didn't want to be agile in name. We wanted to get some change in behavior. It makes it safe and possible to change. In an environment like a big enterprise that hasn't changed the way they've worked for 25 years, and no one there believes it ever could possibly be any different. You can, in one quarter, come in, not disrupt anything, not disrupt any feathers, not do anything that's politically hard, and show that you have made a change. You have just cracked a 25-year problem without ruffling a single feather. Now, the next quarter, you can start to make some changes. And that's the same sort of thing that we're going to do here. So I'm going to look at one of these pairs of contexts, which one I wanted to do. So we're going to look at deployable code bases, separately deployable code bases, this one over here. So my goal is bring this context in. The situation I'm in is I'm working with a team, an enterprise, myself, like pick a scale. Scale doesn't matter. And I've got all the things, all the contexts that lead up to this, right? I've got good unit testing, excellent unit testing. I've got defined boundaries and APIs between things. I've got the ability to ship dark features. What I don't have is code bases that are separately deployable yet. They're all still, in one repo and require builds and that entangle each other. And when I make a change, it impacts other people and all those sorts of things. So let's have a little thought experiment. You're the creative change agent. Hack it. what is the minimum amount of change that we can think we can do to get separately deployable code bases to be an active context in an admittedly extremely crappy, cheated way. Right? So we're looking for cheats here. Can anyone think of a cheat that allows us to get closer to separately deployable code bases without doing very much or any work?
Make a total copy and have the code bases, then start training it.
Or what was that?
Make a full copy of one code base into two different code bases and start chopping up unnecessary bits.
Yeah, absolutely. That's a great one. No one ever said that I needed to eliminate duplication. So yeah, if I have the entire code base and you have the whole code base, then I can deploy my copy of everything and you can deploy your copy of everything. And we can, in the future, delete and reduce duplication and get it so I only have my code. Right? Yeah, that's a good step that reduces it.
I feel like
Other thoughts?
I've seen that in places where like they branch, right? Like I feel like I heard a story recently where someone was like, they branched and they called the branch avoiding future pain. And now we are 8 months later and we need to merge. Right? So like, how do you do that without it just becoming a disaster?
So the key thing on this one is there's no intention ever to merge. It's that what I'm doing is I'm getting to the point that your team has your code and my team has my code. And the way I'm starting is by saying, and we will start by your team having 10 million lines of code and my team having 10 million lines of code. And it's up to you whether you would prefer to keep all 10 million or go down to the 2 million that you actively use.
Have you seen that be successful?
As long as they're not branching with the intention to come back in, but they're instead pulling out my piece. Right? I've seen people pull out either the entire code base or often a large segment of it. So there was when I was at Tableau, one of the groups did a strategy like this, where they took a chunk of the code base that was separate-ish at the organizational level, and they took that, extracted that chunk out mostly, but they still had way too many people who were in that code base. So all of those teams took a full copy of that, and then they eventually broke it out and then split out some drivers and other abstractions and things and and decomposed it down. But
and
initially,
never needed to take updates for the things that were fixed by the other team.
They just quickly turned off anything that was fixed by the other team. Because the whole point was that we're going to separate things that release and work together. And so it's sort of like, it's it's a kind of an inverse strangler thing where I've got all this code and most of it I want to be dead code. And so at any given point where I have a problem and you make an improvement, I'll just kill that branch and call yours.
In order to execute this, you're going to need some infrastructure. Like if it's a service, now you need two services, some way for them to interact appropriately. So it's not just clone, there's some other steps.
You do need something along those lines. You can do initially very close to just clone, but then you do need some more. Yeah. And so that one comes into another part. Well, separately deployable code bases, we all at this point are thinking about, I've got my service running in my container and you've got your containerized service and they're communicating through API boundaries and so on, and it's nice and tidy. But we're coming from a system in which none of that is ever true. Right? So what are some other hacks we could do? Anyone know how Visual Studio works inside?
A little bit.
You might know a little bit, yeah. So Visual Studio, for a long time, they were running into language server problems. And they couldn't handle a lot of languages because Visual Studio's outer host shell was the 32-bit application. And so they had all these memory issues. And they really wanted everything to be 64-bit, but there was just too much code and too many really low-level twinky weird things that had been introduced in 1978 or whenever the hell it was, and issues. Right? And so they started breaking it up. And initially, they had all of these chunks that were separately deployable, except they were deployable as statically linked libraries that could only link against the shell of Visual Studio and only be used that way. Right? So the deploy was a C statically linked library. Then some of those pieces they made into dynamically linked libraries that still, in order to swap out what was running in vStudio, you needed to recompile vStudio. Then they made a little plugin architecture on top of that. And so it was still function calls, so you still needed to shut down and restore vStudio, but you could change a config, shut it down, and reload it, and come up with the new stuff. Then eventually they were able to break some things out to language servers and do services and protocols, and finally break out of the 32-bit memory address space. They got into the context of separately released deployable code bases many years, I've forgotten how many years it was, but many years before they got to the point that they actually could run anything in 64-bit memory. So the key thing is to look at the context here and see what are some hacks that you can do to bring it about without actually solving most of the problems. Because then you still need to solve those problems, but you're solving those problems with gravity pulling you the right direction. Insight. So this is something, when I asked the first question right up the front, somebody mentioned this, and I've forgotten who it was because that was an hour ago. The exact same behavior has different value in different contexts. It's asking, why is context important? If I'm in if I'm in context A versus context B and I light a fire, there is different value created or destroyed as a result of that context. Let's go look at that. That's some relative value. So let's consider two different teams, companies, individuals. Both of them have, coming over here, both of them have defined boundaries, right? They have this context in place, which is that they're using some design. They've got some way that there are producers of APIs, consumers of those APIs, and a way that I can, heck and isolate myself to some degree from changes on the other side, right? And I have a clear way of going forward and so on, right? So I've got defined boundaries. It's not verifiable. I don't necessarily have simulator testing in there yet or anything along those lines. I don't have a lot of other things, right? The APIs are not backwards compatible, right? But they're there, right? Now, we're working on adding this producer consumer map, right? And so we're going to look at two different situations. One has defined boundaries only, and one has defined boundaries and a producer consumer map. And so what the producer consumer map means is that the only way that you can consume the API is to in some way, quote, register for it. So Amazon, for example, has an internal marketplace of services. The only way that I can consume a service is by going into that marketplace and saying, and clicking the magic link, and then it hooks you up and you get to deploy to it, and it gives you the magic keys to call it on live and all of those sorts of things. But that also means that now the system knows who's using what. All consumers are known by a producer. There is a mapping that any producer can look at and see who's using me and how. So those are the two contexts. One has that map, the other doesn't, but they both have defined boundaries. Let's look at a behavior. I'm a producer. I see a big problem with my API. I want to make a change to allow features that are needed by at least a couple of my customers. I have some very loud consumers that say they need this thing. I need to make an API change. If I don't have the map, what is the value of going forward with that feature? Positive and negative contributions to value.
If you don't know, I guess you could be creating a feature either that a lot of people are also going to want without your knowledge ahead of time, or a feature that a lot of people don't want.
The value itself is unknown and unknowable. Right? It could be high, it could be low. I just don't know. Yeah. In addition, are there any negative contributions to value that I could be doing by changing the API to enable this feature?
You could be breaking things for a lot of people that you don't know are dependent on it.
Yeah.
Yeah,
Yeah.
if you don't limit yourself to extending the interface so that it doesn't break
Right.
backwards.
Yeah. So yes, exactly. And that's exactly the chain of logic that happens. It's like, well, I could do this in the nice, clean way that would be good for everybody, except it might break people, and I don't know who it would break, and I can't know who it would break. So I have to do it in a conservative way and limit myself to extension only and backwards compatible changes, which A, requires a set of skills and behaviors and things that I may or may not have. It's sitting over here next to it. I might not have it yet. And B, even if I do have it, it ends up over time often degrading the design of my API because I keep having to do these weird extension points instead of just expressing what I actually want. And so as a result of the economics, the risk, I take an action that decreases the value. And so it has a negative. So the behavior that I want to do, I can't even do because it's too expensive. Right? And I do a lesser behavior. So now let's exactly the same thing, but I've got the producer consumer map. As a producer, I know exactly who all of my consumers are. At the least, I've got Slack rooms that they all hang out in and the names of designated responsible individuals for each one of them. And probably I've got like if I'm like in the Amazon marketplace, that kind of thing. Their code is taking clear dependencies, and in some way that code can be built against my thing. I can get their code and do stuff with it in some way. So now I want to do the same thing, where I've got a feature that a few people have loudly clamored for. I want to make an API change to do that feature. What is the value? What are positive and negative contributions to the value here? All that's changed is the context.
So a negative there is that I am now responsible for fixing all of them. Drives my cost up.
You aren't necessarily. There's a map. I know who all of them are. They have a designated responsible individual, and they're still a consumer of my API.
I have to delay making the change until they're ready.
Maybe.
Okay.
Again, you're skipping a step. So the first thing is I know who they are, so I can know whether there's a problem. Right. So if I get to the point of I have to delay and that slows me down, well, that's a choice that I've made because I had the option to make that choice. Instead of having an unknowable risk that I'm going to just break a bunch of shit, now I've got a well-defined, quantifiable, knowable risk. I know whether I'm going to break a bunch of shit. And I can make a choice about whether it's worth breaking that or not. So even if it slows me down, I have chosen that I can actually afford to be slowed down here, and that is a much better choice than a bunch of shit's going to break and I don't even know what, right? So there is a negative contribution, but it's a much smaller negative contribution there. And certainly, I would like to make that go away with other things that are also further to the right, but I don't have those yet, right? So other advantages or disadvantages, other changes in value by having that producer consumer for the same behavior.
By knowing who's using what, maybe that person arguing loudly for the change is one in a million. And you can actually push back on the relative priority of it.
Exactly. That's what Tom was pointing to. Now it is knowable what the value is. So when they loudly clamor at me before, without the map, I had to have an argument and a long discussion and figure out and wrangle and talk and talk and talk and talk. And now, when they push for it, I send a message out to all 450 consumers and ask, this thing, for each of you, where's it at? And we do one quick vote, and I've got data. And I bring the data to the person and tell them where the answer is. Way less effort on my behalf to get through that relative prioritization conversation, and I get a much better answer, and the ones that are really important bubble to the top, and the ones that aren't naturally fall off. So the key thing here is that the behavior didn't change. All that changed was the activated context. The value is determined by the context, not the behavior. There is no value in unit testing. There is no value in refactoring. There is tremendous value in being in a place where you have good, trustworthy unit tests. There is tremendous value in being in a place where dependencies simply melt away because everyone is so good at refactoring that you don't need to take any effort or make any schedule. It just drive-by refactoring cleans things up, right? As opposed to drive-by coding makes things messier. Right? Those are the contexts, and they do depend on some of those behaviors, right? But the behavior itself does not bring value. And in fact, attempting any of those behaviors without that context can bring strong negative value. If I try and do a bunch of unit testing of code that is untestable, and I don't know how to refactor untested code, it's gonna go bad. There are a lot of different possible bad outcomes. They're all bad outcomes. Right. My next insight there. What I want to look at is, and even the behaviors don't mean the same things. As I change contexts, think of two different contexts here. I'm online and talking about cryptocurrency, or I'm in a makerspace and I use the term hacker. What does that person do? What are the behaviors, the actual behaviors done in the process of hacking in each of those two contexts? They don't have anything to do with each other. And I would argue the same is true about other terms that we commonly banter about, like TDD or unit testing. So has anyone had the experience of being in contexts in which unit testing did not mean unit testing?
Yes. No one else knows how to test.
And what do you mean by that? What is the way to test?
I mean, I remember having conversations around unit testing and CI. Like, I remember having a conversation around CI that involved, we have a build that someone runs every night. And then I remember having conversations around unit testing, where we have people who test the code, right? Where it's like they're not even to the point of automated testing.
Where
Yeah,
the term unit testing came from, where it started.
I was going to say, I've been in an environment where they talk about TDD, but they really mean unit testing. And what they mean by unit testing is unclear as well. So I'm trying to just avoid using that word at all. I prefer micro test or a new way of saying it.
If you use a more esoteric word, you can often get away with that a little bit because the word has only appeared in one context so far, and so it only has the one meaning, but if it's effective, it'll spread, and then it'll still mean different things. Like even micro-testing, for example. Okay, micro-testing, testing things small. Do you use mocks when micro-testing?
On possibly
On the
the
definition of
boundaries.
mock.
What's that?
That's a particularly badly defined word.
A bad word, a
Yeah.
poorly defined one. But yeah, and then the question is, yeah, possibly around boundaries. But there are a number of very different ways to do micro testing. And if you use James Shore's pattern language for testing without mocks, then you don't use mocks, you don't use stubs, you don't use fakes, you don't use any of those
He's still
test
using
configured.
fakes, though.
He doesn't use test configured doubles.
Yeah, that's fair.
He
He does.
edit stubs. Right.
He has objects which have well-defined behavior when their dependency is not present.
Okay.
Yeah, the nullable architecture. Yeah.
Right. The nullable
But
stuff.
he does have stubs and fakes. Like they
He
still
does
have.
in some places he has stubs and fakes. And those are the ancillary things. Like in more of the patterns and the way that the pattern language is guiding you towards the sociable tests, you would use more of the nulled out real implementations.
Yeah.
Whereas if I'm using doing micro testing, but I'm doing it in the tell don't ask architecture style, every test is configuring some sort of a mock, because that's actually the behavior I'm trying to test, is did it pass this message to that thing, right? And I've got a completely different behavior, and every test looks entirely differently. So even something that's well defined isn't, and it depends again on the contexts. So
there's this whole thing with LLMs where they take a word, like just the English version, and then they vectorize it, and then they modify the vector of the word based on everything around it. And I feel like there's a similar process going on here, where you're saying like it's the context around the word that actually is making the definition of the word.
Very true. Agreed. And those contexts are knowable and they're categorizable, which is one of the key things. And that's what makes the LLM actually work, is that they are in some sense knowing and categorizing those contexts so that they have the vector of the word.
Yeah, and then to some degree, like the vector of that is more powerful than the actual words that we get.
Absolutely. As a result of the last two statements, this is the corollary. Any plan or advice that crosses contexts will invariably either look stupid or be stupid. So as an example, let's try and construct a plan, and then we'll try and construct some advice that crosses context without it either looking really stupid to the receiver or actually being really stupid. And I don't believe it will be possible, but hey, let's see if we can prove me wrong. So first, let's consider a plan. So I am sitting here making my roadmap of technical change, right? And I want to look at what we're going to accomplish over the next year. And let's say that our current state is that we are in the context where before refactoring is safe and cheap. We're over here on the left. We've done some stuff maybe with some defined boundaries, but refactoring is still expensive, painful, still contains risk. It's more often remodeling than actually refactoring. We don't really know the difference between those, and we certainly don't practice named code transformations with static analysis. Right? So it is not safe and cheap yet. Okay? Now, we're looking at a year, and in a year, I, as the expert who is making the plan, know that we're going to get to the point where we not only have refactoring safe and cheap, we've got the ability to verify boundaries independently, which depends on that, and are at the point where dependencies are melting away. They're naturally just going away because of drive-by refactoring, which is safe and cheap. I'm making the plan and talking about what deploy will look like. Things that will make any plan that I state look stupid. So what are some facets of the plan that I'm going to include of how we're going to deploy? If I'm assuming that the context is dependencies are going away over time without intentional effort or guidance from leadership in any way, that I can verify all the boundaries independently. Refactoring is safe and cheap. How are we going to handle integration and deployment between teams?
Are you asking about before we've gotten to that state?
When I'm in that state, how would we handle deployment? Like, what would be the wise, correct, effective way when all of those are true to be handling deploying? What sort of processes are we going to put in place?
You should automate your deployment, and it should go out as soon as all of its tests pass.
It should be fully automated, go out without a human check. The tests pass, and so I know that the boundaries are good and the dependencies are interacting correctly, and it should just go towards live. Yeah, and certainly to dog food. I should just be dog fooding the automatically deployed thing. Now, it's a year before that, and I'm sitting here where refactoring is unsafe, and there's no way in hell I could verify these boundaries.
Seems kind of stupid.
Yeah, it seems kind of stupid, right?
Pretty far away.
So my choice is I could either make the plan and state the plan of what we're going to do, at which point it seems stupid. Or I can make a plan that we're going to do things based off of the current situation right now, in which case it is stupid. Because I'm going to spend a year building up a ton of procedures to do those manual reviews in a very effective way and create jobs and people that we hire to do those manual reviews that now I'm going to have to figure out how to fire.
I think it only seems stupid if maybe you've never seen it done, or you've never seen it done well and you believe that it can be achieved. So yeah.
Why that seems stupid. When you're in the prior context, and most of the people are, and they've been in that context for some time, and you present a plan that is, here's the way it's going to work, their answer is going to be, that's dumb. You will break everything. And I'm just going to step back and let you do what you want to do and watch you fall on your face. And because they all step back, you actually will fall on your face because no one will actually make the changes that would be necessary to get you there. Experiential blindness. Exactly. Right? And so we're in this situation where, because the context is changing over the next year, I cannot make a plan that looks that far out without it either looking stupid or being stupid. I can only make a plan, I believe, one context shift out. And even then, it helps a lot if I've already semi-activated that context. If I've done some of the cheap hacks and gotten it to be to the point where I'm pseudo doing independent deploy with everyone having their copies or whatever else, then now I can say, yeah, our deployment strategy, for so long as we're working on this and going a little bit after, is going to be pretty much exactly the same. And we're going to tidy it up, and it's going to get smoother and better, but we're going to deploy things independently and into our integration lab, and then we're going to verify them there, but we're going to automatically and independently deploy to verification lab. And everyone goes, yeah, that makes a ton of sense. You won't be taking down the integration lab all the time because we've already got this here.
So a takeaway here for a coach or a leader is be really particular about which behavior changes you want to introduce when, knowing your current context and which context you want to move to. Don't do them too early. I wonder which behaviors don't have a context dependence. Is there a few that are always applicable, or is that a null set?
Found any technical behaviors that are context independent. I have found social behaviors that are, for example, mobbing. And it tends to be the behaviors that are all about rapidly improving learning and decreasing feedback cycles. So mobbing, pairing to some degree, although that's got enough downsides that there are social contexts that it applies or doesn't apply to.
Retros.
Doing some form of periodic reflection, retrospective, whatever you want to call that, in some way. Several of those seem to be context independent. And the way that I even execute the behavior doesn't change that much as I develop the context of the code. Right? The way that a mob behaves changes as the mob gains more experience at mobbing. Like there is an internal context and skill set there. But if I take a mob with the same skill and I drop them into ugly, crappy code without a lot of uniformity versus drop them into something that's uniform and clean and has good tests, they don't mob any differently. And I shouldn't not mob in one case. They just do different technical work. But yeah, those are the exceptions that I've been able to find. I have yet to find any technical skill that remains unaffected by context. I have found some technical skills that show up in different forms in different contexts, but show up in a lot of different contexts. So refactoring is one of those. Remodeling, if I consider it as changing the design of existing code while working to minimize risk. Right? There is a way of doing that in any number of different contexts, and it's important in also all of those contexts. The way that I do that is very different, and so it's a very different behavior.
Yeah, is both the approach you take to minimize the risk and the consequences of those risks. I definitely see both engineers and non-engineers misunderstand the risks there, so that's a tricky one.
That's true with all of them. Unit testing blinds you to the. It can breed a sense of false confidence very easily. That's one of the risks that it creates. And so depending on the context, that has more or less impact and more or less probability.
I wonder if safeguarding is universally applicable.
Oh.
Go under the learning category.
It definitely is under the learning category, but it might. Yeah, that might be universally applicable. So it still doesn't break my thesis, but I hadn't thought of it as one that's universally applicable. Yeah.
Speaking of universally applicable, maybe there are some fundamental laws and principles that affect behavior of the mob. For example, you mentioned how deadly unit testing could be, or at least the presumptions around it. And if the engineers know, for example, what Dijkstra said and believe what he said about testing, that it can never be used to prove the absence of bugs, but only to demonstrate their presence, then they'll take a more humble approach to testing coverage. And this is something you and Llewellyn and others have, done a great deal with. So maybe there's fundamentals that need to be introduced, and sometimes they're introduced socially, sometimes they're introduced through formal education. There's any number of ways.
Yeah. So I do find that there are absolutely mindsets, mind frames, mental models, however you want to describe those, that significantly impact the way that people do a broad range of behaviors, and that those will alter the risk profile greatly. Value profile some, but the risk profile tremendously. I also have found that, at least for my own efforts, any effort to teach those directly has been pretty useless. It doesn't seem to be that people pick up a mindset and then from them do the right behavior. But if I give them a class, I give them a set of experiences that are all the behavior done the right way for a number of different behaviors, they independently reinvent the mindset, and they're wonderful inventions.
Because you're modeling that for them.
I'm modeling it, and I'm even stronger than modeling it. I'm giving them very carefully selected and curated experiences
To make it stick, or
Yeah.
for them to even discover, aha, for
Exactly.
themselves, the same thing.
Exactly. So I'm it's like I'm taking them to the top of the tower with the wooden ball and the iron ball, and dropping them both and just walking away. And then I take them to another place, right? And I give them 3 or 4 different experiences of the way the gravity works. And then I let them noodle on it, and I point out what, that's interesting, isn't it? Right. And they'll reinvent gravity. But I can't, if I just tell them about the law of gravity, they will never figure out how to do any of the right applications of it.
Now, Peter Code used to always say, the example teaches.
Mhm.
It's very strong.
It really does. The example and the experience. These days, if you look at the way I do all of my teaching, it is entirely about getting them to notice a thing and then take a specific action. Just noticing is the hard bit. And so I get it down to one thing that we're going to work on right here and now, and I'll actually frame it and put it in front of them. They'll start having an experience, and I'll say, now notice when X, and then when that happens, do Y. And that's all I want you to do for the next day. Anytime that doesn't happen, do whatever the hell you want, right? But notice when X, and then do Y, and that'll get you the experiences. And those will happen enough in your real code. I don't need to do any lab or anything else. You'll experience those, and then 2 days later, I'll give you a different thing to notice and action to take. And that's how I build up those experiences from which they then can do the sense making.
That sounds great.
Thank you. It took me a long time to get to that form. It's only within the last 3 months that I've been teaching it that way. Okay. That really is the end of the set of insights that I have found and written down. I will not in any way claim that this is a talk with order or a through line or a story. These are simply a number of things that I've noticed as I've been going through the effort of trying to record how is it that I see people change, and what is technical excellence, and the path that we get used to get there anyway. Hopefully you found it interesting and thought-provoking and challenging some of the ideas, maybe giving you new ideas. But honestly, I think my goal, I know my goal here is to break existing ideas open so that you can fill them in with something new. With that, I'm happy to go open-ended. I'm happy to call it here. It's been 90 minutes and perhaps somewhat cognitively involved. Certainly a lot of metacognition and thinking about things. So
That was great. I just had a question about this. This diagram here, is this live anywhere that other people can look at, or when will this be published soon? Or
I plan to make this live before the craft conference. The craft conference is in early June, late May. And I do not know on what date it will go live. And when it goes live, it will have both the diagrams and some of the stuff there. And also it's got some things I put in here. I'm putting in some applications and tips, and these are a lot of recommendations based off of the kind of content and reflections that I just described to you, right? How do you choose an effective mentor? and think of not just one mentor, but a set of mentors over time. And where is the span for which I want one mentor, and what do I look at for these couple of contexts? And if you're mentoring, how can you be effective at mentoring different kinds of things? How do you support your team as it's going through those changes? How do you make a roadmap that is able to avoid either looking stupid or sounding stupid, and yet still provide directional advice and budgeting information to a group? And so, yeah, I'm going to be trying to write up a number of those supporting materials, as well as get at least one map out by the craft conference.
So Arlo, what should we follow in order to be aware of your progress? Or do you have a list or a place that you disseminate these?
Yeah, so I
revelations?
will, when I do release, I will certainly announce it on both LinkedIn and Twitter, or whatever Twitter calls itself now. And if you're actively interested in conversing on it, I think that would be awesome. And I will put my email address in here. There we go. And it might even be on the YouTube live stream now for everyone to see there. But reach out. I don't have any formal mechanism, but this is, I'm doing work on this every day now, between now and then, and I would be happy to share conversations and get more thoughts in there.